Hello, my name is Jamie Harris, and I'm going to be covering the concept of nodes for Solobuster and Open Referrals Data Management Library. What are nodes? And nodes are a way that we're going to represent data so that we can reconcile our records, map columns, find duplicates, and perform other mutations and transformations on our data easily without the need to reconcile a table of normalized data. And whenever we reconcile a table of normalized data, if we find phone numbers, for instance, that are duplicates, and we want to try to reconcile those phone numbers, well, we have to then join that to, we'll say, we have a table called addresses. So we're going to have to join the addresses, and the addresses are then points to locations, and then locations points to our organization. So we're going to have to create 4 joins, and we've got a ton of data that we got to reconcile to dedupe those phone numbers if they are in fact duplicates. And we don't know that until we join the tables, and it can get quite messy. Nodes, hopefully, is going to help us solve these issues a little easier. And with a node, we're going to represent the data as a single immutable point. And in our case, we're going to represent that data by physical location. And representing the data as a physical location, there can't be any 2 locations that exist at the same exact place unless if that data points to the same location, right? So we're going to represent that data as a physical location. And any 2 organizations that points to the same location, we're just going to put those records inside of that, what we call a node. And doing that, if we find that that physical location has more than 1 phone number, it's going to either be nested in a single array, or it's going to be in an array of arrays, and then we can hopefully merge that data, right? So once we perform our operations on that data, then we can normalize those tables back out. And a one-to-many relationship would just be an array nested inside of this document. Okay. So at the end of the day, we're hopefully going to be able to cut through complex joins and a couple other problems that we have to solve in reconciling large data sets, as well as canonicalizing data. Now, whenever we canonicalize data, we've got to do some quite complicated joins, and we got to make sure that that data represents the same object. Well, we have to describe that object in a certain way. And with nodes, we are describing it in a certain way. And in our instance today, we're going to describe it by location. Let's look at some source code and just kind of dive into what I've been working on today. And hopefully it makes sense. So the first thing that we're going to do is we're going to get some imports from the library, Solobuster and Open Referrals Library. You'll find the link in the comments. We're going to read our data into a data frame, and our sheet that we're working with is agency, which represents agencies, and those agencies are going to have 2 columns, a latitude and a longitude column, and that's how we're going to key our nodes. Now, our nodes are going to have 7 fields. One of them is not listed here. I'm going to have to add it in, and I'll just talk about it here, or actually I'll go ahead and add it in. We're going to have our node name. Our node name is the way that we organize the data. In the case of today, we're going to be organizing the data as location. So the node name is going to be location. We're going to have our node ID, which is a UUID. Our node key. Aliases. Our aliases are going to be the raw data from a data provider. And each alias is going to have a source column, a source key. And node key, aliases, formatted attributes, and views all are stored as JSON. So aliases are going to be our raw data, and we're not going to mutate that data at all. Alias is formatted whenever we ingest data. Alias is formatted as a copy of aliases. However, this becomes our working data, so we can perform any mutations to that data and do whatever we want to with it after we ingest it, and we still maintain a copy of the raw data, the source data that we bring into the database. Attributes are going to be derived information from the aliases data, and let's say, for instance, we have 10 addresses all representing the same address, and we'll say Google API to reconcile these addresses to the same address. So in attributes, then we can have that address to live in attributes because we've reconciled all that data that, one might be 123 Sesame Street, one might be 123 Sesame ST, right? And we want to represent that in a way, and we can then store that in attributes. In views are going to be derived representations of that data, such as an HSDS3 format. So that should be an on-demand process, I'm thinking, where you can hit a node and a function then is going to return your HSDS3 format from that node, and then views at that point would be more like a cache. So we're going to cache the function, and if that view exists, then we can return that from the cache. Okay, basically we're going to initialize our nodes with a database handler, and this is how we're going to read and write to the nodes table. Our log handler, and you can look at previous videos or our documentation for the logs and the logger. We're going to need to pass in a node name. In our case, it's going to be location, and then log changes if we want to log the changes. And this is going to inherit from the base iterator class, which is basically just a class iterator. We do override the getItem method of the base iterator, and you can retrieve an item using a key of an integer, which is going to retrieve just the index. Also, you can pass in a raw key, and in this case we could retrieve an item by passing in a dictionary that contains latitude and longitude, and then it's going to parse that key and return any nodes that match that key, and it should only be one node, right? And if we pass in anything other than an integer or a dictionary, then we're going to return, we're going to try to find a node with the index of the key that's already formatted. Some basic properties here representing our database log handler, log changes as well as name. All right, now upon initialization of this class, we're going to use the fetch query to build our fetch query, and this also will accept optionally a node key and a node ID so that we can filter those records. The fetch method accepts the same. We're going to retrieve the data, and we're going to instantiate a node class for each record, and that's going to be our base items for iteration from the nodes class. Persist is going to save our nodes instance to the database, and we're going to be using a batch query here. So we can get up to 13x faster on writing to the database on each persist. And the main function that we're working with today is ingest. So created this nodes class and node class concept to first ingest records, and I'm going to be working with these classes in the next couple of weeks. Some videos will follow. Right now I've got the ingest method here, and that's what we're going to be viewing today. The ingest method is going to take in some data, and this data is either going to be a data frame or it's going to be a list of records. Node key fields is the columns in the data that we're going to create our node key from. And our node key, if you remember, is going to live in the database as a dictionary, and that's going to be our raw key. Then our final key, our formatted key, is going to be that raw key sorted. We're going to strip away any new lines, white spaces. We're going to concatenate that string, and then we're going to lowercase it. And then our source data, or our source parameter, is going to be our data provider, where we got the data from. So here we're getting the records either from the data frame, or if it's a list, we're just setting it equal to the data equal to records. Anything else is going to raise a value error. We're going to iterate through each of the records, and we're going to take one of 3 actions, and we're going to log that action, each action. The first action is if we find a node with the same exact key and that record does not exist, we're going to append an alias. So let me say that one more time. So if we pass in a record for ingestion and that key, the latitude and longitude, is already in the database, then we're going to append that record as a new alias. Now, if the key exists and the record exists, then we're going to skip it. It's already in the database. And then if that key does not exist, we're going to create a new node. We're going to log the changes to the database, and those changes are going to be logging the action that we took, which is create node. We skipped it because it was a duplicate alias in the node, or we appended an alias to the node. We're going to log the ID of the node. And then, just like with any log, we're going to have our job ID and our step name. So if we ingest 4,000 records, we expect to have a job ID for 4,000 records being the same. And we're going to return, finally, the job ID, the total count of the records that we ingested. The third item is going to be how many new records that we created nodes from, or how many nodes that we created from the records. How many nodes had aliases appended to it, and then how many duplicates we skipped. So we're returning a tuple of job ID, total count, a new nodes count, appended records count, and then duplicates skipped. And then our node class, just basic properties mapping our database. Our raw key is the dictionary, and our formatted key up here is where we're concatenating all the items that sorted by key. We're stripping new lines, white spaces, and we're lowercasing. Okay, so here's it all running and what it looks like. We're going to instantiate the nodes, and this is going to actually read in from the database those nodes. we're going to ingest that same sheet that's in data frame format, and we're going to key it by latitude and longitude. And finally, we're going to pass in the source. And I've just ran this recently, so we can see the job ID that returned. We can see how many records we tried to ingest. We didn't create any new nodes, and we did not append any records, and we had 4,135 skipped because they already existed. I'm printing out the node key of the first one here, and this is the key formatted. I'm printing out the aliases of the first node, the ID of the first node. Here is the raw key. We can see latitude and longitude. There's no attributes yet, and we expect that. And here I'm going to ingest it again, the same exact data, and we're going to see the same exact results. Printing out the aliases once more. Now I'm going to persist it to the database, and now I'm going to print out how many nodes I actually have. Okay. Now what I'm going to do is I'm going to run this again, and we're going to see the results from the database. I'm going to drop all those records, and then we can see different results. All right, so we're back, and let's look at some of the data. Right now, we are still ingesting a second record of nodes. The first record has been ingested, so let's go back down here and take a look at it real quick. We can see that our results printed out, and I wiped the logs clean. I also wiped the nodes clean. Here we've got our job ID. We processed 4,135 records with 2,163 nodes created, and 1,972 nodes were already in existence. So we appended that many records, and we had no duplicates in this set. Printing out the first key, the same as before. And this is going to be a rather lengthy process because the logs it's not use and execute batch, it's just use and execute. That's something that I need to change in the future to speed that process up. Right now we are at 6,000 nodes, but what I'm going to do, or 6,000 records. So each run is 4,135 records, and we should only have 2,163 nodes because the rest of them are going to be duplicates. Well, we don't have any nodes yet. We haven't persisted them. Okay, so anyways, whenever we persist these, we should only get 2,163 nodes, and we'll take a look at this in our next video. But anyways, one improvement that we're going to have to improve upon is using our logs to execute batch so that we can reduce the round trips to the server. And I've already verified these results, so running this twice, we're going to only have 2,163 nodes. And the second run, as in the first portion of this video, we saw that there were 4,135 records, and we had 4,135 duplicates, and there were only 2,163 nodes, which means that we're able to ingest these records and only see our duplicates. And that's exactly the results that we want. So that's the first portion of the nodes, is ingesting our data into a location, key by location, creating our keys so that we can then identify nodes that are matching whenever we ingest it right off the bat. And we're going to be performing some mutations coming up, and we're going to improve obviously improve upon the library and make the logs function a little more, a little less round trips to the database. So we'll see you in the next video, and let's hope we make some decent progress.